Aloha and welcome to the next lesson. In this lesson, we're going to be talking about interacting with file systems. So specifically, we're going to be working with the OS module. And the OS module is going to allow you to interact with your computer's operating system and access files. So different operating systems, they treat files differently. So each installation of Python is going to have the type of OS modules that are specific to that computer's operating system architecture. So that's why you have a Macintosh version, you have a Windows version, you have all these different versions of it, because they have the things that are specific to the operating systems. So in this, we're going to be talking about the OS module. And one of the things we talk about is compatibility, portability. When you're writing code, you want to be writing code in such a way that you're really not writing it specifically for the operating system that you're operating on, because you may be running something, let's say on a Linux system, and you want to take that over to a Windows system at some point, or maybe you're making code for others to use, and somebody decides, hey, I want to run this, but I want to run this on a Windows box, and it turns out that because you've made your code in such a way that it is written for Mac and it can't run on a Windows. So we try to aim for this thing called portability. It means you can take it. It's portable. You can take it from one operating system over to another. So this concept, we call it portability. And particularly in Python, and when you're dealing with file structures specifically, what this really is talking about is the way you address file names. You're going to find the Windows uses backward slash, and it uses the drive name in the beginning, like C:/ and then the name of the file and everything. And then you're going to find in Windows and Linux, it's using forward slashes. So let me go ahead and share the screen here. And I'm going to bring up VS Code. And I'm going to run this because it's going to do nothing. But if you look at it, you see that in the Mac, we have forward slashes here. So we have forward slashes for all of our things. When we're dealing with file structure in Windows, we're going to see different things. Instead of having this as the root directory, you would see something like C:/ and then backslash and different things like that. So that's something that you don't want to be programming directly into your code. And I had a nice bad example of that in a previous lesson where I was taking this path right here and showing it to you, but we can clean that up using different things that are out there in the OS module. And that's what I want to introduce you to today. So a couple of things here. Let's go ahead and import our OS module. So this comes in the standard library. So we've got the OS module. And the first thing that I want to show you is something that I use a lot, and they don't have it here in the lesson, but this is something that will be helpful to see. And it's the getCWD, os.getCWD. And what this does is it gets the current working directory, so you can see where you are. So if we run this, it's going to tell me that we're currently running from user John Johnson. So this is the directory that we're in. So that's great to know, because I've got a file here, and obviously file is not there. It's in users John Johnson desktop ITS 128. So this is in a totally different place. So you see that it's this right here. So you can combine things to make you can do some combinations of different functions to make some directories. So let's go ahead and try some of these. So let's go ahead and take a look at, what shall we start with here? Well, first of all, let's start with the path, the os.path.join, because that's an important one that you're going to see a lot. So we're going to take this thing, we're going to take a file name, and we're going to say, we're going to just create a new file. Let's say we're going to write out to a log file or something like that. So in order to do something like that, we're going to have to make a path. We're going to have to make a file name essentially with its folder path in front of it. So we're going to do os.path.join. So what join is going to do is join is going to go out there, and it's going to combine these names into the proper directory structure using the OS specific separation markers, whether it's a forward slash or a backward slash. So it's going to handle that for us. So what I want to do here is I want to join the os.get current working directory. I want to combine that with, let's say, a log directory. We'll make a log directory. So we'll have that as a directory, and we'll just add log file.txt as the name. So then let's go ahead and print that out and see what we get. So this is going to be interesting because what we're doing is we're using the OS specific pathing, and we're going to combine the current working directory with the directory of log, and we're going to connect it to this log file. So we go ahead and we run that. We're going to see that we get users forward slash user John Johnson, because this is the current working directory. And then we're going to store it in log, which is the next directory that I created, and then the log file.txt. So we're creating this file. So this is how we can safely do this. And you can take this code, move this to Windows, move this to wherever, and it's still going to work. The only time that we're going to have trouble is if we go up here and we decide that we're not going to do something agnostic, operating system agnostic like this, and we're going to hard code it. Because if we go and we do this, all of a sudden what I've done is I've taken what was portable, and I've made it unportable, because this right here is only going to work on Mac and Linux, because it's using that type of absolute path structure. So you don't want to really do this in the real world. You want to do something that's going to be portable across operating systems. So keep that in mind. So there's other functions out here that are useful when you're creating things and working with the operating system. And the purpose of this lesson is to really see a lot of the different functionality that we have out there. So we can do something that's considered the inverse of os.path.join, and that's going to be string.split. So if we were to take something like let's go down here, and we're going to say, we're going to start with a print here, and we're going to say string.split, and that is going to, oh, hold on. Let's not do that. Let's take the file name dot split and put in, oh no, actually, sorry. We're going to be using the string dot split. This is a function that's available to the string object. We're going to say os.path dot separator. So let's see here. Yeah, so this is the construct that we can use, string.split for OS of path separator. So this path.sep is giving us the separator that's used for that specific operating system. And then we're going to be able to split strings depending on that. So instead of using string here, we're going to use file name, which we have already created. So we're going to take our file name that we created up here, and let's change this back to that nice os.get current working directory. So we're going to go down here, we're going to print it out, and then we're going to take that name that we just got, and we're going to split it by the separator specific to that operating system. So what you're going to see is we have taken this thing right here, then we're going to split it. So when we run that, we're going to get it broken up into all the tokens that it has. So in Windows, we're going to be seeing a drive over here, and then we have the users, which is the first part. Then we have John Johnson, which is the next directory. Then we have log is the next one. It tokenizes essentially our file name and our file with its path. So we get each element of that down to the file name. So that's kind of the opposite of doing a join. Join puts it all together. Doing the split here takes it all apart. And you can split it using the operating system specific separator by using os.path.sep. So that's useful when you're dealing with building and deconstructing file names. So we're going to move on from this one, and we're going to take a look at using the os.path.split, and that's going to give us the directory and file name, and that's also kind of cool. So if we were to take the previous example of file name, let's go ahead and we'll let it print it out. But what we're going to do instead here is we're going to try to, one of the things you'll often find is you want to get the file name for something, and the file name's there, but so is the entire path. So how do we get just the the file name part out of it. Well, we can do a split, and then the split will give us the all the directory name in one side, and then the second element is going to be the file name. So if we're to do, let's try doing this as an unpack. Let's say path file equals file name. Oh wait, actually no, we're going to do a os.path.split of file name. And then we will print what those two parts are. We're going to print the path, and then we'll print the file. So let's see what that gives us. So that gives us, all right, so we look at this. This is our full file name right here. Or this is our full file with the path on it. And then we get the path part as part one, and we get the second element in there, the 1th element actually, is logfile.txt. So that's a nice way of breaking down this long file name with path. It's the way that you get one part or the other. Sometimes you want the path. Let's say you're going to save another file in here in the directory that this thing is in. Let's say this is a log file and you want to create a new log file. Well, you'll need the path part. So if you use this the os.path.split, you can split that name, get the file part, and then create a new file name for it. So that's a convenient tool to have in your tool chest. And that's just another one of these OS functions that will help you out when you're dealing with operating with the file system. So another thing that we often do is we check for the existence of files. And sometimes you want to know if those files are, if it's a directory or if it's a file itself. So we can use this thing called os.path.exists, and that works on both files and directories. So you can see if something exists based on that. So let's go ahead and try to do something. So we've got a file name, which is up here. Let's just test to see if this exists right here. Let's see if just either one of these directories exists. So we can do, we can use the os.path.exists, and then we can put in, we can hard code this. This won't be a problem, but if we were to, say on this, does this, exist, and throw it in there, and that's a directory name. If we run that, oops, yeah, we need to actually print the results in order to understand if it actually did. So let's go here and print the results of that and close the parentheses. And we have an error here still. What is the error? I don't, so no, that was a name, sorry. So if we run that, we get true. So that path exists, and of course it does because we're referencing off of there. But if we put in another character there, which I don't have that directory, we'll see that it goes to false. But not only does it work, as we said, for these directories, it also works for the files themselves. So we're going to self-reference example.py here. We're going to run this. It says false. Why is that? Have I misspelled it here? Yes, I have. It's examples. So we go and run it again, we get true. So this can work on both files and directories. So that's another neat thing to have. Sometimes you want to know specifically whether you're dealing with a file or whether you're dealing with a directory here. So it's a good idea to check here. And we'll go ahead and say, we use the isFile thing. So we're going to say print os.path. Oops, OAuth is not it, path is file, and we're going to put in our file name here. We're going to hard code this for this one example, and we're going to say, is it a file? And when we run this, let's take this out because we don't need to get confused there. We'll go down here and we'll clear this as well. And then if we run it again, we're going to get true. That is a file, and we expect it to because this is what we're looking at. Now let's see if it's going to tell us the directory is also a file. Is the directory a file? No, it is not. So now we're going to move on to another thing here, which is you're probably going to get the same, you're going to be able to catch what we're talking about. Instead of this file, let's say we want to see if it's a directory. So we can do is directory named isdir, yay. So if we run isdir here and we, let's clear this so it doesn't confuse us. Then we run up here, we play, we get true, it is a directory. If we put in there examples.py, What do you think we're going to get? Should get a false. There we go. We've got a false because this is a file. It's not a directory. So these are nice little tools that you can use to interact with your operating system or your file system and find out whether or not these files, whether or not these things you have, whether they exist, whether they're files, whether they're directories. Another thing that you may want to do is get the size of something. So let's go ahead, and of course there is a function for that as well. It's called simply get size. We're going to get the size of this file, and when we run that, we're going to see that it's 197. Now, here's something that's confusing. You might think that if you look at ITS 128, the directory here, you could get the size of the entire directory. That is not how it works, though. If you run that, you're going to see 197 for the size of examples, whatever, and 384 for the other. This is actually the size of the inode that describes the directory. It's not actually the size of everything in that directory. So don't worry about inodes and things like that. That's really operating system specific things that we don't need to deal with here. But just know that trying to get the dir size, you are using the get size, sorry, it's not going to give you the size of what all is in your directory. It's only going to give you the size of the inode that gives you information about that directory. So use get size really to size up your files. And we can combine this with other things that we have out there to, we can calculate the size of a directory in other ways. We could do a traversal of the directory structure, and that's something we're going to talk about next. It's called the os.walk, and that works in the following way. Let's say we want to, let's go ahead and delete out this right here, because this is not really what we're going to be using. What we want to do is we're going to do a walk of the directory. So it's going to go through the directory, and it's going to go down each subdirectory. And as it's going through there, it's going to return a tuple that has your directory name, the subdirectories, and the files at each level. So I want to do a directory walk here. We're going to do, let's say remember, it gives us the directory name, it gives us the subdirectories, and it gives us the files in os.walk. So we're using the walk function from the OS module, and we're going to give it a directory name. And that directory name, I'm going to be lazy again, and I'm going to grab this here and use this directory. And remember, oops, I should have done that. This is not good coding practice because I'm making it specific to the Mac here by using these forward slashes and everything. But I'm doing this just for our little example here. So forgive the non-portable code here. But we're going to do, what we're doing here is we're extracting the directory name, the subdirectory, and the files for each one in here. So what we're getting here is an iterable object, really, and it's going to give us this tuple at each iteration here. It's going to have the directory names, the subdirectories, and the files. So we'll go down here and we'll print out that, and we're going to take so for here, let me do a paste because I'm lazy. But if we decide we're going to print out the directory name, the subdirectories, and the files at each step, this is the code to do it. We're just going to use an F string, say directory name, print out the directory name, the subdirectories, and the files. And then we can go in here, and it's going to loop through there because this os.walk is, it's sending out a tuple each time it goes through there. So if we run this, let's clear out here so it's pretty. And we're going to go up here and we're going to run it. And we see a bunch of stuff come out. So we're going to go back up here to the top, and we're going to look at the directory structure. The first level was this ITS 128, and I had two subdirectories in there. I had this PyCache, Dunder PyCache. I had level 1, which is just an empty directory that I started. And then I have the files in there are names.txt, It gives me all these different files that I have in there. Then it goes to the first of these subdirectories. Well, actually, no, it goes into PyCache first. I apologize. So yeah, so it goes into PyCache. So it's looking at PyCache, and it has no subdirectories, and it has one file in there. Then it goes to level 1. So it looks in directory level 1, and then it sees that there's a directory in there called level 2. And the files it has at level 1 are dsstore and level1.py. So then it goes to level 2. And inside level 2, I have another folder named level 3. And the files in level 2 are these. So you see how it recurses through the whole thing. Look, it goes down the tree, looking at each branch there and coming up with those. And if we wanted to calculate sizes of directories and everything, we can put in math here and use that get size to get the size of the files as we go. So that's something that's kind of nice. So we could do something like at this stage, we could I could do something along the lines of, we could print that out, but then we could do a for file in files. And I'm running slow here. So for file in files, we can say something along the lines of, oh wait, this is gonna get messy because we're gonna have to combine that that directory with it, because the files is only going to give us the file name, so we're going to need to join those. So if we did something like this, we would I want to say, well, let's go up here, let's create something called sum and set it to 0. Yeah, I'll just call it sum. It's really going to be total size, we'll call it. So we've got total size. This is going to give us the total size of our files here. So we're going to go file and files, and we're going to say total size plus equals, plus equals, and then we're going to go back and we're going to use that os.path.get size, and that is going to give us the size for that file. But we're not going to be able to just do the get file and use the file here because that doesn't have the total name. We should get an error. And just to show you that, let's run the, or wait, hold on. So then we'd want to do a print at each step, and notice that it's going to give you a printout of it at each step of the, as you add each file to it. And then what I'll do is when you first go into it, we will zero that out again so that we can reuse it. So we'll go down here after it finishes, we'll say total size equals 0. So it'll give us an error because we haven't combined the path name with this. So I just want to show you, this is organic growth of a program. This is iterative programming, but let's just show how we do get the error. And it says no such file or directory names.txt. So up here, we would do what I mentioned before, which is os.path.join. And then we would join we'd join this string up here. Oops, hold on, let me got ahead of myself there. So we're going to join the string, and we're going to join, or wait, no, that's get size. Where was I at here? I've lost myself. Oh, here we are. All right, so we're going to join right here. We're going to join the directory with the file, and this should give us the thing. Again, what I'm doing here is not good form, because what I'm essentially doing is I'm hard coding this for Mac or Linux, what I'm working in right now. Forgive me, we'll work on that later, but I'm getting an error here, which means that I'm not fully closing something out, and that is correct. I haven't closed out my bracket here. So let's go ahead, clean up down below. And after clearing it, I'm gonna run the program, and we're gonna get an error. And why is that? No such file or directory, and it's giving us this do nothing.cpython path.pyc. So that is going to be a problem. Oh, I know. So I shouldn't be using that hard-coded thing right here. What I should be using is what they're already giving us, which is the, if you look up here, it's giving us the directory name each time. What I should be combining here, which would make this kind of agnostic, operating system agnostic, is the directory name. So if I put in dir name here, and I reran this, because it'll work for the top level directory, but after you get into subfolders, it's not going to work. So, and again, the reason I'm showing it to you this way is I want to build it organically so you can see me making mistakes, because we make mistakes all the time. We build things up bit by bit, and it's natural to run into an error, look at it, figure out what that error means, and then work around that. So that's what we're doing here. So we're going to go ahead and clear this out again. Then we're going to go back up. We're going to hit the play button, and we're going to get, you'll see that it actually ran. So we're going to get the sum of these two files is going to be, so the first one must have been 6148, and the second one was 68. So what we could do really to clean this up, because this looks atrocious, you're looking at numbers and not knowing what they are. So we know that we're going to go ahead and delete that out. Actually, I shouldn't delete it. I should have just moved it over to here. So we're doing a print of total size after we go through all the files. So, and of course, we're just printing out a number. That's not very pretty. So let's go and F string this thing. So we'll say F, and then we'll say total size in directory, and we'll call it dir name is, and then we'll say total size. And that will be nice. And I apologize, my voice is going to be running a little bit faster than my browser here, because I'm using Zoom to record this video, and Zoom lately seems to have a bug in that the processing or running the video and the screen sharing here, it'll record everything at a nice rate, but for some reason it gums up the typing. So I've already typed everything that's in here at the beginning of my talking. It's taking it a while to catch up. So if you'll forgive that, I'll get on with this. So we finished it. We're going to close out that. And now we should have it look nicer. Now it's going to say total size and directory is, and it's going to total size and directory, whatever is total size here. So when we run this, it's going to look a lot nicer. So it's telling us the total size and directory, whatever, is 720. So that's nice to know. And we could make that even nicer, because you look and it says files or whatever, and it doesn't tell you what the name is. But actually, yeah, for now, let's just leave it as that, because we don't want to individually go through each one. We could do a line in here and just say, you know, the size of file, whatever is whatever. And let's just do it because we're having fun. So I will come over here, and I'm going to be lazy and reuse my print thing here. I'm going to say, yeah, let's just say file, and then we're going to take the file name that we're working on, file, and then we're going to say has size, and then we'll come over here and we'll use this. And we're going to say we're going to use our little function that we use. We're going to do the os.path.getSize. And again, this is running a little bit slow. We'll say file, catch up with me, os.path.getSize, and then the file. And after that, we'll go ahead and close it out. And that should do, let me see. And just a little bit more here, and we'll be ready to hop, skips, and jumps. Okay, so now if we run this, we should get an error, because everyone gets errors, right? Maybe I'll get lucky, we'll see. So we run and we get the error, yeah. So That's why, again, what we need to do here, remember, we need to do this os.join because we need to, when we're doing the get size, we have to have the path and the file name. So we'll just replace file here with what we had up here. And then when we run that again, we're gonna not get the error, and we're gonna get this nice little thing. So every time we go through, it's gonna tell us file whatever, has size whatever, and then it tells us the total size is gonna be 68, which is the combination of these two together. So this is how you kind of can use, these functions together. You can use your the os.path.join up here. You can use your get size. You can walk through the directories and do things on the files. So this right here is a neat little tool that you can do to get subdirectory sizes. And you can have something, if you wanted to, you could also do we'll just call it mega total size, and have that set to 0 up here. And then we could find out at the bottom of everything what the entire size of the, all the directories and the subdirectories was. We can do that by setting this mega total size equal to 0. And then what we'll do is we'll come in and where we do the adding to our, hold on, over here where we do the total size line, what we can do is we can just duplicate this, and we can say mega, there we go. So we just select that, and it'll, if we put in mega total size, this is going to essentially add it up, and it's going to keep on going till the end. And then we just take this, and it's great to be lazy and just copy things. So that's what I'm going to do. I'm going to put that here, and I'm going to move it to the top level because we want this to run after we finish our entire journey. So hold on just a second. Okay, there we go. So we want this after we do our entire OS walk. We want to say total size in directory. And this is no longer going to be directory here because we're out of the loop. It's going to be the one up here. So we're just going to copy this and put that down here. And I know this looks chintzy, but this is the way we're going to do it. I need to take out the single quotes though, because the single quotes are going to make it die. So we'll take out the single quotes there. And we're going to say the total size in the directory such and such is, and then over here we say, I think we called it mega total size. So we say mega total size. And after doing that, we should get little subdirectory sizes over here. We're also going to get the big total overall count. So if we go down here and we clear out our file to make it nice, then we go back up here, and this is taking a second. Then we run it. Then what do we get? We get, oh yeah, total size in directory such and such is 25,439. So this is going to be the summation of all the subdirectories that we found leading up to there. I'm not going to actually test that out right now, but I trust that that is correct. So anyways, and because this looks just like that, you can say something like the entire size, which is kind of lame sounding, but we can also change up here. We can just say, we can take out this and say size and subdirectory. Maybe that's the best way to do it. We can just say, well, no, let's back that up and say size and directory. That way we can kind of distinguish between the subdirectories and the total directory counts. When we run that again, we get the size and directories giving us the subdirectory sizes. And then we have the entire total size and directory is 25,444 megabytes, or kilobytes, I think it is here. So that is a deep dive into messing around with the OS module. And there's a lot more functionality out there in OS, but just know that when you are out there trying to work with operating systems, when you're trying to do things that interact with files, when you want to do things like copy them, delete them, do something with it. It's not just reading and writing to files. We can use this OS thing, and it can do all kinds of neat stuff. So we can delete we can delete files, we can delete directories, we can do all kinds of stuff. Just know that all that functionality is out there. It's in the OS module, and just dive into it. You can take a look and see what all is available in the OS module. But this is an intro to it. So I hope it's kind of piqued your interest for the OS module, and I hope you've gotten a good idea of what you can do here. But it's quite powerful, and I use this stuff all the time when I'm creating files or doing things. Analyzing log files is something you may often find yourself doing, and when you go out to save out your stuff, you're going to need to check, hey, does that directory exist? Create a file for it, things like that. So this is going to help you out. So anyway, if you have any questions about anything we've talked about here, send me an email. If you want some one-on-one instruction, send me an email and say, hey, let's set up a Zoom class, and I can do a one-on-one with you. So anyway, take care, and I'll see you in the next lesson. Aloha.